Oh, it says it's recording. All right. All right. Welcome back. Um, we're going to move on to the next section, which is 13.8. Hope you all are doing well. Okay. So you're going to have a word problem where you're going to apply what you know about the sine and cosine graphs and stuff like that. And it is the Tarzan problem. So it says Tarzan is swinging back and forth on his grapevine. As he swings, he goes back and forth across the riverbank, going alternately over land and water. It says see the figure. So here's Tarzan swinging back and forth. Here's the land. Here's where the edge of the riverbank is, and then there's the water. So he's swinging back and forth over land and water. Jane decided to mathematically model his motion and starts her stopwatch. Let y be the number of meters Tarzan is from the riverbank. So y is the distance from the riverbank. Here's the riverbank. Yeah. Assume that y varies sinusoidally. That means we can use sine or cosine with t, where t is time, and that y is positive when Tarzan is over water and negative when he's over land. So that's why it says y is positive 17. He's going as far as 17 here, and then negative 23 when he's over land. Yeah. Okay. So Jane finds that when t equals 2, Tarzan is at one end of his swing where y is negative 23. She finds that when t equals 5, he reaches the other end of the swing when y equals 17. They want us to sketch a graph and write a particular equation and then predict and all of that. Okay, so here's what we know. They gave us that when time was 2, right, your y is negative 23. And they gave us that when the time was 5, you reached the other end of the swing. So when y is 17. So I know I've got those two values. We know it's sinusoidal. Yeah. So let's start with, before I start graphing it, let's find some information. Do you remember that the amplitude is the maximum minus the minimum divided by 2? Right? So, and it's the max y values, max y value minus max min value. And so 17 was the max minus the minimum was negative 23 all over 2. So that gives you 40 over 2 or 20. So that's going to be your A value. Yeah. But they actually, we're going to start at negative 23. So you actually start down low. So you'll see that we'll end up having they started down low and then went up high. So it's actually flipped upside down for I'm going to do cosine. Right? You'll see because we've got the max and min values. So flip, so that means your A value is going to be a negative 20. The period is going to be, well, I guess I need to graph it first, huh? Right, let's graph it. And then we can find what the period is because they haven't quite given it to us yet. So let's come back to that. Let's pause that. Let's graph it first. All right. So draw my x-axis, draw my y-axis. And what I know is the maximum value he goes is positive 17. And I know the minimum he goes is a negative 23. Yeah. And then I'll just do 1, 2, 3, 4, 5. That's what I know so far. So I know when time is 2. So here's time and here's y. Yeah. So I know that when t equals 2, we were at negative 23. So I got this dot down here. And I know when t is 5, I've got positive 17. Yeah. And so here's the minimum, here's the maximum. So if you can imagine it doing like that, because it tells us it's sinusoidal. So from 2 to 5 was 3 units. So that means 6, 7, 8. Another 3, after another 3 seconds, right? When t equals 2, you're down here. When t equals 5, you're up here. That was 3 seconds in between. After another 3 seconds, you will be back down. You'll be back over at negative 23, like that. And after another 3 seconds, 10, 11, he'll be back over at the maximum of 17, was it feet? Whatever. I don't see where it says it, but anyway, yeah. And then you can also, to continue the graph, at 2, it was at negative 23. So it 3 more seconds before that, which that makes sense mathematically, right? At negative 1 here, he would have been at 17 there. And so, again, do, 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 and something like that. There we go. All right. Because they gave us a min, they gave us a max. That ends up being just half of the period, if that makes sense. And in fact, do I have a highlighter handy? No, I'll just use a different color. All right, so notice that now it'll make sense of why I said that it was flipped upside down, right? You can see from here to there, did I highlight? There's one period of cosine, but flipped upside down, right? Because normally cosine is the cup and it starts up high and goes down low. But now your first point from the values they gave you were to negative 23. So you started down low, went up high, came back down low. Okay. So really I should have started graphing it first so we could look at the picture. All right, so then now does it make sense that your period is going to be from a peak to a peak? So from here to here is the period. Yeah, of an upside down, flipped, negative, yeah, cosine. All right, so the period would be 8 minus 2. So the period is 6. And what we want to be able to get the equation is to find b. But we know that the period is equal to 2 pi over b. And so solving for b, you would want to multiply both sides by b. So you'd get a 6 times b equals 2 pi. Dividing both sides by 6 will give you a b equals 2 pi over 6 or pi over 3. So that'll be your b value. Right. Then we've got, we need C and we need D. So your C value, if you remember, is the first tick mark of your period. And the first tick mark of the period I chose was 2. So that's going to be your C value. And then your D value, remember, is the middle Y value. Yeah? What is the middle Y value? So in between 17 and negative 23, what's the middle there? So one way to do it is just to go 17 plus negative 23 divided by 2, which would be what? Negative 6 over 2, so negative 3. So let's say this is negative 3 here for the Y value. Does it look like it's about the middle? Did I do a good job? Ish. Probably shouldn't, but not too bad. All right, so middle Y value is negative 3, so that'll be your D value. Good on that. And if you check it, what's this distance? From 17 to -3 would be 20 units. How about from -3 to -23? That would also be 20 units. These are your A values. Remember, A is from middle to the top and middle to the bottom. So you can totally confirm that whenever you choose whatever your D is, make sure that if you add A to the D value, you'll get your max. If you subtract A from your D value, you'll get your minimum. That's always true with all of these trig graphs. Okay, so now that we know A, B, C, and D, we can write this. Again, I chose cosine because of the values they gave me. And so your equation will be y equals A, we said was -20 times cosine of B. I guess I should have written it. We're going to write it as A times cosine of B times, we're going to use T because they gave us time and they told us T. So T minus C and then plus D. So we got B is pi over 3. T minus C was 2 plus D, which was a -3. There's the equation. That's the particular equation expressing Tarzan's distance from the riverbank in terms of T. And if you plugged values in, right, when you plug in a 5, you better get 17 in there. You know? And when you plug in a 2, you better get -23. When I plug in an 8, I better get -23. When I plug in 11, I should get a 17. Now, if you plug them in, you'll see that it all works. Okay, so that was that. So that's part A and part B. So that was part B. Part C says, I'll slide this down so you can see what it says. It says predict Y when T is 2.8, 6.3, and then also when it's 15. And that's easy. You're just going to plug these values in. So when T, so part I, now, when T is 2.8, then your Y will be -20 times cosine of pi over 3 times 2.8 minus 2, and then minus 3. Simplify that before I put it in my calculator. 2.8 minus 2 will give me a 0.8. All right, so keep in mind, I know my writing looks like this, but when you put it in your calculator, cosine will start a parenthesis, and you really are taking cosine of that part. The B is always factored out the way we write it, but when you take the cosine, it really is B times everything that's in the parentheses. So make sure when we put this in our calculator, once you hit cosine, it'll start a parenthesis, end it after the pi over 3 times 0.8. The -3 is after it has taken cosine of that angle. Okay, so let's put this in our calculator. Find a good spot to put it. There we go. Okay, clear. I am in what mode right now? Rad mode. I need to be in radian mode. There were no degree symbols in any of this problem. They didn't give it to us in degrees. They gave it to us in time. So radian mode is what you will be in for this. If there's not a degree symbol, it is radians. So we got -20 times cosine. You don't have to hit the cosine in front. It will multiply that. I'm going to just write 0.8 pi over 3. Now, 0.8 times pi over 3, so 0.8 pi divided by 3, and the parenthesis, and then -3. So that I get y is about -16 point, did it tell us where to round to? It didn't. I'm going to go to 2 decimal places. All right, so 16.382 tells me 3.8. And, oh, it said meters. Y was in meters, so meters. how about when part 2 was predict when the time was 6.3. All right, so we'll plug that in. Negative 20 times cosine of pi over 3 times 6.3 minus 2. 6.3 minus 2 would be a 4.3. And keep in mind, it's cosine of, that is the angle, 4.3 times pi over 3. So that, you put it in your calculator. So negative 20 times cosine of 4.3 pi divided by 3, and the parenthesis, 4.3 times pi divided by 3, and then minus 3. All right, I get 1.158. So that 8 says round that 5 up to a 6. So 1.16 meters. Let's stop for a minute and compare these numbers to our graph before I do the last one. Does it make sense? Yeah. This is saying when t is 2.8, I've got negative 16.38. So 2.8 would be almost 3. Yeah. So down here, does that look like about negative 16? Sure. Why not? If that's negative 3 and that's negative 23, it's a reasonable answer. When time is 6.3, I'm saying that it should be at 1.16. So 6 and just a little up, well, probably right about there. There's 6.3. Yeah. And sure enough, 1.16, or maybe it was a little bit further over. Whatever, but you get the point. Like it should be it should match your graph reasonably anyway. It may not be exact because we don't graph it perfect, but you shouldn't get some 30, positive 30 when your graph is showing like a negative 2 or something, right? It shouldn't be crazy. It definitely should not be off like that. All right, how about part 3? T equals 15. Why don't you pause the video right now, write this out on your own. You can do it, yeah, and then come back and confirm. Yeah? Try it on your own. Yo, yo. Yo, yo, yo. Try it on your own. Pretend that I'm walking around. I'm walking around the classroom. Okay, pause. Okay, hopefully you tried it on your own. I can't monitor you, right? You do you, but hopefully you're trying to learn this stuff. All right, so we should have gotten a negative 20 times cosine of pi over 3 times 15 minus 2, and then minus 3. So what does that become? That becomes a 13 pi over 3. And hopefully you remembered, in that parenthesis after the 13 pi over 3, now, so I've got a negative 20 cosine of 13 pi divided by 3. And the parenthesis, minus 3. Boop-a-doo. Did you get negative 13 exactly? I don't need to put the little squigglies of approximately. Hopefully you got negative 13 meters. If you did, give yourself a pat on the back. If not, what did you do wrong? Try doing it again, yeah? Okay, so let's look at it compared to our graph. Oh, well, I'm not even on the graph, right? When t equals 15, so let's see, it would have been 1, 2, 3. If I continued it, that's 12, 13, 14. And remember, 3 more units. 11 was up there, yeah. So 1, 2, 3. At 14, I would have been back down here. Yeah. And then 15 would have been the very next one. And then 16. At 17, I would have been back up here again. Yep. So if you cross over, at 14, it would have been like that. And like Yeah. And at 15, you are definitely down here. And apparently it's exactly 13 meters. Isn't that nice? Nice. Okay. Last question they want us to answer is that where was Tarzan when Jane started her stopwatch? Started her stopwatch. So, looking back at this graph, right? This is my horizontal axis is time. So, did it really make sense for me to write this -1? Time equals -1 second, right? Was it second? Was t in seconds? Did it say? I don't see it anywhere. Whatever. I'm going to assume seconds, right? Because I can't imagine it would take them a full minute. Yeah, so yeah, seconds. Okay. T equals -1 makes 0 sense, right? So theoretically, our math model shows that. But in reality, right, we've only really got this positive t value. Time is positive. And when she starts the stopwatch, that would be when t equals 0. Yeah. So part D, she started the stopwatch at t equals 0. Yeah. All right. So looking at my graph, t equals 0, slide it down, would be on the y-axis, right? So somewhere here. So I'm expecting a positive value, and I'm expecting a value that is less than 17, right? But bigger than 0. So let's figure out the exact value. We got y equals -20 times cosine of pi over 3. Plug in a 0 for t now. -2 minus 3. And so that gives you a -20 cosine of, -2 times pi over 3. Guess what? That is a value you should know. You should know cosine of -2 pi over 3. Yes, you have your calculator, whatever, but cosine of 2 pi over 3, -2 pi over 3, -2 pi over 3, this would be -1 pi over 3. This would be -2 pi over 3. It's like a negative 120 degrees. 60-degree reference angle. Yeah. Makes that a -1/2 and that a -3 over 2. So cosine of -2 pi over 3 is -1/2. So this should be -20 times -1/2, which gives you a positive 10 minus 3, which is 7 meters. Yes. This part of the chapter, you can use a calculator, but since you still need to be, you still got to do the one without the calculator, right? Better to just keep practicing. If it's a special angle, practice that what you know, right? But if I put it in my calculator, -20 times cosine of -2 pi over 3, and the parenthesis, and then -3. 7. Yeah. So you can always confirm it with your calculator. Okay, that's it for the lesson. There you go. You only have a couple of problems, but they're all application problems like this. Work it out and come see me in office hours if you need to. As of right now, I wasn't planning on doing it. They don't want us to start office hours until Monday. So that's what I was planning. So I'm trying to still record all these videos for you all. But if you need me, you text me or send me a message through Google Classroom. Either way, let me know if you have questions or you need help or you just need to talk to somebody, right? Hopefully you all are FaceTiming or whatever you guys do now to communicate virtually, right? Hopefully you all are still staying connected that way, just not in person, so that way we can get this virus under control, right? Get it under control so that we can get back to life as normal without and reducing the amount of people who get infected and especially people who get severely ill. So, all right, you guys have a fabulous day. Let me know if you need help, okay? Bye, guys. Maybe it takes a second for me to stop recording. Stop and